day, sir. I am Nicole Zamji de los Reyes from BSE2B. I am here recording this video to discuss to you how I solve assignment number 5. The problem in assignment number 5 is referring to figure 2, change RA to 0.2 ohms, RB to 0.3 ohms, and RL to 0.5 ohms with the same battery polarities. And with EA is equals to 24 volts and EB is equals to 26 volts, as shown, calculate A, the current IL, IA, and IB, B, the load voltage VL, C, the load and battery powers PL, PA, and PB using source transformation method. The source transformation method, this method simplifies the number of meshes in the network and thus simplifies the number of equations needed. Given there are two voltage sources, which is EA is equals to 24 volts and thus a polarity of positive negative, and EB is equals to 26 volts and thus same polarities positive negative, and connected to resistor RA is equals to 0.2 ohms, RB is equals to 0.3 ohms, RL is equals to 0.5 ohms, and thus current A, current IB, and current IL. So, to solve the problem using source transformation method, we go to step 1, which is transform the voltage and current source to their equivalence. So, the voltage source EA is series to resistor RA. To transform ISA or current source A, it is equals to EA over RA. The value of our REA or current source A is equals to 24 volts over the value of our RA is equals to 0.2 ohms, then we will get 120 amperes. So, current source A is equals to 120 amperes. And EB is series to resistor RB. So, ISB or current source B is equals to EB over RB. EB is equals to 26 volts over RB is equals to 0.3. Then solve, is equals to 260 over 3 amps. So current source B is equals to 260 over 3 amps. So since it has same polarities, we can add ISA and ISB. So current source is equals to ISA or current source A plus current source B. So substitute the value 120 plus 260 over 3. Then IS is equals to 620 amps. Then step 2, simplify the circuit diagram. So the sum up of the current source IS is equals to 620 over 3 amps and transform resistor and it become parallel. So RA is parallel to RA is equals to 0.2 ohms parallel to RL is equal to 0.5 ohms, and RL is parallel to RB is equals to 0.3 ohms. Then step 3, solve IL. So to solve IL, it is equals to 1 over RL all over 1 over RA plus 1 over RB plus 1 over RL times IS. or current source. So so 1, then substitute the value, it is equal to 1 over 0.5 all over 1 over 0.2 plus 1 over 0.3 plus 1 over 0.5 times IS, which is 620 over 3, IL is equals to 40 amps. Then to solve, current A or IA is equals to IS or current source all over 1 over RA plus 1 over RB plus 1 over RL. Then substitute the value, 620 over 3 all over 1 over 0.2 plus 1 over 0.3 plus 1 over 0.5. Then solve, we will get IA is equals to 20 amp. Then to solve IB, we can apply KCL. IA plus IB is equals to IL. Then transpose IA to this side, we will get IB is equals to IL minus IA. So IB is equals to IL minus IA, then substitute the value. So 40 minus 20, so IB is equals to 20 amp. Then solve for VL, we can use VL is equals to IL times RL. Then VL is equals to IL times RL, substitute the value, 40 times 0.5, we get value of our VL is equals to 20 volts. Then to solve PL, PA and PB, we can, in solving PL, we can use PL is equals to IL squared times RL. Then substitute value, 40 squared times 0.5, PL is equals to 800 watts. To solve PA, power A, we can use PA is equals to VA times IA, substitute value, 24 times 20, so PA is equals to 480 watts. Then solve for PB, it is equal to VB times IB, then substitute the value, 26 times 20, PB is equals to 520 watts.